Welcome to Maths with Mrs. B. In this lesson, we're going to look at the equation for a circle. And you can see in the first diagram that we have a circle with a center at some point on the Cartesian plane. So the equation of a circle is given by the formula x minus a squared plus y minus b squared equals r squared. And r is the radius of the circle. And this formula should be familiar in the sense that it looks like the formula for distance, which we learned in grade 10. So let's have a look at a simple example where we're given a circle which has the center at the origin. So we can use the formula of the circle and substitute the values for the center into the formula. So the first one, a is equal to 0, and the second one, b is equal to 0. And when we simplify this, we have x squared plus y squared is equal to r squared. And that's the simplest formula for the circle, and it's what it will always look like when we have the center of the circle at the origin. So in this example, we need to substitute the center value that we were given into the values for a and b in our equation. So we're going to substitute that in place of a, and we're going to substitute in place of b. And then we can substitute the value of the radius in place of r in our formula. So let's go and do that. So we have x minus 1 squared plus y minus negative 3 squared equals 2 squared. And the question has just asked for the equation of the circle. So we just need to simplify the equation so that we have everything written in simplified form. So that's going to become plus 3 squared, and we can write that as 4. And that is the equation of the circle. So this type of example is straightforward. You just need to substitute the center and the radius into the formula. In this example, we are given the center of the circle, 4, 3, and we are told that it passes through the point -1 and 3. So we're not given the radius here. So what we can do, first of all, is substitute in the center of the circle into our formula. So we always substitute in the center with the opposite signs. And then once we've done that, we can look at the point that we're given, and that is actually an x coordinate and a y coordinate. And so we can substitute those coordinates in place of the x value and the y value in our expression. And so we use the same signs that we're given for the substitution. So -1, 4, 3, -3 equals r squared. So you can see here that the only unknown is r. And so we can work this out. We're going to get 25 plus 0 equals r squared. And we can stop there. We don't need to work out what r is equal to. We need to just have r squared because we asked to work out the equation of the circle. So we go back and we substitute in the r squared into our final formula. And that's the final answer. In this example, we are told to determine the equation of a circle whose end points of the diameter are given as 6, 14, and -4, -10. So it's helpful to have this in a diagram so that we can see what information we are given and what information we can get from what we're given. So if we have a look, here is our diameter, and here are the coordinates of the points that we were given. But we know that the midpoint of the diameter will be the center of the circle. So we can actually go and work out the center of the circle by working out the midpoint of those two values that we're given as coordinates. We can just substitute the values in. And now we have the values for the center of the circle. So now we can go and use one of the other coordinates and substitute that in along with the center so that we can get the equation of the circle. So we have x minus 1 squared plus y minus 2 squared equals r squared. So what I've done is I've substituted the 1 for the a value in the center of the circle and the 2 for the b value in the center of the circle. And now I can go and substitute either of the two other points into my equation. So let's just choose the positive points and go and put those in place of x and y. So we have 6 minus 1 squared plus 14 minus 2 squared equals r squared. And we can work this out. Now that we have our r squared, we can go back and we can write the equation of the circle with all the correct values. And now we've answered the question. This example is slightly different. We need to find the equation of the circle in the diagram. The points that are given on the diagram are the y-intercept at this point here, which is the coordinate 0, 8. And then we're also given the point of contact of the circle with the x-axis, which is the coordinate 4, 0. But that doesn't help us because we still need to have the coordinate of the center in order to substitute into our equation for a circle. So we need to find an expression for the center of the circle so that we can substitute our coordinates in here. So if we have a look at the point of contact, if we join that point of contact with the center, we actually have the radius, and that radius is perpendicular to the x-axis because of the theorem which says the radius is perpendicular to the tangent, if you remember from circle geometry. So what we have is this length here from the point of contact up to the center of the circle. That is the radius, and we can call that r. We don't know the length of the radius, but we know that we can represent it with the value r. And if we look at what that value would be on the y-axis, whatever the radius value is, that is going to be that same value on the y-axis. The distance from the point of contact to the radius is the same distance from the origin to the same point on the y-axis. And so we can call that value r, and we can see that that is going to have a coordinate of 4, and then whatever that value r is. And now we can use these two coordinates, 0, 8, and 4r, to substitute in place of our x and y and our center coordinates in the equation. So let's go and see what that looks like. So if we substitute 0, 8 in place of the x and the y, and then if we substitute the center in place of a and b, we can now go and simplify this equation, and you can see that we only have one variable as the unknown. We have it here and we have it here, and that is a good thing. That means we can solve for r. So let's go and work this out. So what I did here was I just squared -4 to give me 16, and then I squared this whole bracket in order to give me the trinomial here. Now we can solve for r. This r squared and this r squared will end up cancelling out, and so we end up manipulating the equation so that we have our numbers add up to 80, and we can add 16r to both sides so that we can get equals to 16r. Then we can divide both sides by 16 to get r on its own, and we end up with r is equal to 5. And we know now that r squared will be equal to 25. Now we have both variables that we can go back to our original equation to substitute. So we're going to make r equal to 5, and we're going to make r squared over here equal to 25. So we just go back and substitute in the relevant values. So what I've done is I've replaced the r with 5, and I've replaced the r squared with 25. Thank you, and see you next time.